So how do I write that in mathish? P.
Less than 8.
Yeah. Less than or equal to 0.55. So where's that go? The whole. Yes. Why? Because it has an equal sign. If you weren't here yesterday, I feel bad for you. Watch the video. Thank the gods you have a teacher that tapes your shit. I'm not giving myself props. I'm just saying it's out there for you. So what's this? Should be ha. Oh, well. What's this one? Greater than 0.55. How many tailed tests will it be then? One tail. Of course. There's no equal or not equal to, right? What always sets up my rejection region? Which one of these? The ha does, always. Anybody that has an equal sign in it, I can't show evidence for that. So we forcefully, the claim doesn't go in the ha or the. It's just if it has an equal sign, it's the. If it doesn't, it's the ha, right? So the claim could be either one. But we set it up so it's always the ha sets up where the rejection region is. So where will the rejection region be? I want to give us a rough sketch. Yeah, up here, greater than. So one tail test. And just to remind you guys, all that means is, in order to show evidence this is true, I gotta find a sample that is so far above 0.55 that it must be true. If I just get a little bit above 0.55, well, that could happen randomly. Beautiful? Yes, that's exactly why I can't just go 0.56 and go, I'm done. It's gotta be so far above. I like it. That's why in a trial it's not, did you like the guy that, you didn't like him? Okay, he did it. Next case. You gotta kind of build the evidence up a little more than that. Yeah, I didn't like him. Really? All right, you did it. Bye. No, we don't just here. We gotta weigh this shit out there. Can we use z-scores? Look how nice I'm being. I didn't even give an option for t because I don't know if you remember NPQ problems. You never use t-scores. T-scores were invented for when I don't know sigma for mean problems. Maybe. That's why there's only one formula for the confidence interval for percentage, and it's got a z-score in it because you never use t-scores with NPQ problems. T-scores were not invented to be used for NPQ problems. They were invented for means. But can we use them here? Don't just say it's P, so yeah. No. What do I check? Say what? Sorry? Nope. N is not good enough here. This is NPQ. What do I check? NP and NQ. What's N? 996. What's P? You should just be able to tell me. No work done. 0.55. I like it. And then 996 times point. What's Q going to be then? 4 fucks. All right, let me stop for a second. Everybody cool with that? What's the first place P hat's going to come in? Here. That's the first place I care about my sample. Is down here. So what are those? That's obviously going to be bigger than 5. So this is like 547. Is it? Neato. So then this one's going to be 448.2? Aha. And those are greater than 5. Check. What does that mean exactly? That check we just did, what does that mean? The distribution is normal enough. I like it. In fact, it's basically one of those killed 5, right? Yes?
It's so similar to how for the other ones, if we're looking at the n is greater than 30.
Beautiful. So for means, it's just n has to be bigger than 30. For percentages, you have n and you have the p stuff. They got to work together. That's why they're both involved in that check.
It's just 5. I think that it's always going to have to be bigger.
Yeah, it's sort of like 30.
Okay.
30 came out because most distributions become normal after that. 5 came out because that seems to be enough room for it to go up and come back down. Never forget, that's where that 5 really came from. If I get it out to 5, that's enough room to go up, come back down. There's a little more to the story, but it's not much beyond that. Yes?
Does that mean that Q and P together need to be bigger than 5, or each one independently has to be?
Each one. Each one has to be bigger than 5. So if that was 550 and this was 4, no, can't do it. Okay. Or you can't do it in stats 1. I keep trying to plug stats 2 and everybody's like, I don't really care. You're not making me want to take it. All right. So can we use them? Yes. So rejection region. I can use z-scores. I don't need degrees of freedom. I know I can use z-scores, but I'm still going to use the t-chart. Right? What's alpha? 0.005. How many tail test? 1 tail test. That's all you need to know. What's that value for the cutoff?
4.645.
Careful. 0.005, right? Should be 2.57. Yeah, 2.576.
Yeah.
Does everybody see that? So let me make sure. Alpha's 0.005 and 1 tail. So 1 tail, 0.005. I want a z-score, so I'm just not going to stop. Need a part like a z-score. There it is, 2.576. If I stop, I get what? I get a t-score. So if you want a z-score, just don't stop. Woo! So how do I say this in words? Let me shade that in for myself and that's visual. If no z star is greater than then we can reject the hoe. Support the high. Yes. Are you cool? All right, you ready? Are you cool with those 2 statements right here?
Yeah.
Okay. So just look in the 1 tail, 0.005, right?
Yeah.
And go all the way down and get a z-score.
Yeah, go all the way down to the bottom.
If you stop, you get a
Okay.
t-score.
So always get the larger ones with the system.
Always go to the bottom. Yes.
Because it says right here.
I know.
Yeah.
Yeah.
Okay.
Always go to the bottom. Okay? All right, so what do we know from the sample? We know n is, what was it, 996? Bless you. Bless you. What's x?
594.
Good. The number of successes, 594. So what's p hat?
594 divided by 976.
Yeah. 594 out of 996. I think this 5 9s. Can't remember now. 596. Somebody help me out.
596.
596. All right, let me stop for a second. Is everybody cool with that? I want to point something out. Do you see how little information I gave? So in percentages, I barely have to give you anything because once I know P at and P and Q, it builds everything I need. So I don't really need to give that much information. So I got 594 out of 996. So I got this percentage. So now I've got everything I need. Well, well, we already have Q and P right there. So we got my data, 0.596, minus what goes here?
Minus
0.55 from the claim. We're assuming that is the middle, divided by the square root. What's P? We just put it down, didn't we? 0.55, right? Isn't that what P is? We just put it down, it must be what P is, 0.55. So what's Q? Yeah, we figured that earlier. Divided by 996. All right. So let's see what we get. Now it's going to be our Z star. That's how far away the sample is. Okay. Dude, yeah, killed it. Oh wait, I left out my phone. There we go. That's better. You guys getting that for the Z-score 2.92? All right, I'm going to finally address this. I don't know if anybody has noticed that's shown up on a few other things, but I didn't want to put too much on you the first day. Right now, I can tell the answer, right? Where's 2.92? Yeah, it's in here. So what can we do? Reject the ho, support the ha. So it kind of makes sense. We made it into the rejection region, so therefore we can reject the null. Sometimes math people, we name things correctly. Sometimes we name them ho and ha. Oh well. The p-value, all right, can somebody tell me on that picture, where is alpha? On this picture, where is alpha? Where's alpha? Let's be very specific. It is the part that is shaded. So it's the area in the tail that what's called the critical z-score makes, the benchmark z-score. You guys with me? The p-value is in the area of the tail that my z-score makes. Can anybody find out, and this is an old question, what area is above 2.92? What area is in here? What's the probability that z is greater than 2.92? You gotta look it up. Get your z-score charts out. Oh shit, now we're going old school. T-score chart not will help here. So 292, I get 9982. So 1 minus that is 0018. I like it. Right? Because if you look up 292, do you get this area? No, the chart tells you areas that are below the z-score. So 1 minus that, 0.0018. Stay with me. I know. So this is a much more accurate way of delivering information about what the results of our test were. Did we just barely pass this test? We killed this test, right? I mean, we had to be past this, we're like, oh yeah. This, stay with me. This is the probability that the sample we took just happened to be this far up, that the mean is in the right place, or that in this case the percentage, 0.55, really is in the middle. So that is the probability that the percentage really is in the middle, the 0.55. Is that very likely? So it is much more likely that the actual percentage is higher than 55%. Right? No? So that's the chances that given the 0.55 is in the middle, that we would get a sample where we got it. So the actual population percentage is 55%, and I take, 996 people? Shouldn't I get close to 55% if that's right? Did we get close to 50? No, we're way the shit out here. There's only this percentage chance, 0.18% chance that 0.55 is the real middle, is the real percentage of the population. So what's more likely? That's wrong. That's why I can reject the null. I can reject the guy who thinks it equals that. And I can support the guy who thinks it's more than that. So I'm going to pull up, while you guys are working on the back, I'm going to pull up, we have to finish this conclusion, but yesterday I pulled this up and forgot I had it. I want to show you what they tell you in a study, in a statistical study. I want to show you what they show you, and they show you the p-value. They show you this. So, what is really good evidence if the p-value is high or low?
Low.
Beautiful. The lower the p-value, the more evidence that something's changed, that it's not where the middle was in the hypotheses. It's different. So that's why in an article they're just going to report the p-value, and then you can make up your own mind. If it was 0.07, that's not very small. That's kind of small, but not very small. Like, that's not good enough evidence for most people, but some people it might be good enough evidence. So in an article they just report the p-value. Here you go. Make up your own mind. Have a good time. Try to replicate my results even. All right. So let's finish this one up. You guys will start working on the back. So, which one of these is going to guide me in my conclusion writing? What was the claim? Which one? The hoe. Right? Does everybody see that? The claim was the hoe. So I want to use this language, not this language. Because I want my conclusion to talk about what the freaking claim was. It only makes sense. So you're never like, I'm just going to pick one, reject, support. No, you know exactly what to say. So did we succeed? We made it. So we have found sufficient evidence. So what?
Reject.
So yeah, good. Reject the claim that what?
At most 55%.
Yeah, where'd it go? Oh yeah, so now you can just plagiarize. At most 55% of Chicago. How do you say that? I was afraid to say this. So Chicagoans have an unfavorable view, or I could just say, don't like the police. All right. So this is an actual study that was done in Gallup. It's got a little more detail to it. This is one thing I picked out, one question they asked. So, you guys do the problem on the back.